Hello students, our today's question is the major product of the following reaction is, here we have our starting material is ketone compound and our first reactant is this pyrrolidine. It is a base. So this reaction is the example of Stork enamine reaction. In this first case, this carbon oxygen double bond of this electron, oxygen is more electronegative. So this bond's electron will shift towards the oxygen side and this carbon becomes the partial positive charge. Here the base nitrogen having the extra lone pair of electrons, so it will attack on this side and we get this type of intermediate. In this intermediate we will have that plus or minus H plus shift. This from hydrogen from this nitrogen will first step it eliminate and nitrogen will complete that 3 valency and it gain its lone pair of electron will be back, and this migrated H plus will shift towards this oxygen side that containing a negative charge. We get this hydroxyl group. Now this lone pair of nitrogen will further react and form the double bond, and this hydroxyl group will be leave and we get this iminium salt. Now that migrated H plus will abstract this proton and the bond and carbon hydrogen bond electron will shift toward this side and we get the enamine. Now this enamine, the lone pair of nitrogen will further react and this alpha carbon group will becomes a nucleophile. In our second reactant, that is this allylic bromide, and here negativity of bromine is high, so it will become partially negative and this carbon become partial positive. This partial positive carbon will attack on this alpha nucleophile alpha carbon that contain nucleophile and we get this product. In this case, this iminium salt, this side it has 2 alpha carbon position, 1 and 2. 2 is the more substituted, so enamine cannot be formed at this side. We will get enamine on this position, that is alpha 1 position. That Br minus that will eliminate in this side, it capture this acidic proton and we get the further enamine like this. Now in this enamine, the lone pair of nitrogen can further react and it will shift this double bond and this alpha 1 position become nucleophile. Now see here, cyanide group, that is electron withdrawing group. So it will withdraw the electron from this carbon-carbon double bond and this double bond become partial negative charge containing, this become partial positive charge containing. So it will react like this. This is nucleophilic alpha carbon will attack on this side, and in acidic condition here C minus carbon will have this proton side, so our final product will be like this. And so our today's question's correct answer is option A.